guys, we're back. We're back for part 2 of our chapter 15 lecture on non-renewable resources. So we had just talked about the National Arctic Wildlife Refuge in Alaska. You should be able to locate that on a map. We are now on number 11, which is looking at advantages and disadvantages of like that typical conventional oil that you're going to get out of the ground with like a drill. We talked about fracking. We talked about how you get it out typically. So I would definitely add a positive here. Oh, I just threw my stylus. A positive here that says easy to transport. That's a big one. That's one you're going to see on the test. Okay, so it's easy to transport. You do want to somehow indicate net energy yield. That is going to be important in general on this test. Net energy yield is medium. You can get rid of the but decreasing. We don't need that. If you're just drilling, we're not destroying a lot of land. Oh, it does say efficient distribution system. Way to go, Simek. And I would say we have an okay supply. Less than coal, more than some others. Some disadvantages here. In the next unit, we talk about oil spills quite a bit. So we have some water pollution issues. We are not utilizing full cost pricing, so it's not that expensive to buy our gasoline, to buy our, other products from oil. And it does release CO2. The other thing that we'll talk about, which fracking kind of helps with, is we're dependent on foreign oil, right? So like fracking makes it a domestic source. This is an economic issue. So we're dependent on foreign oil, and the international supply interruptions are kind of a task. There we go. All right, so there's also other ways to get oil. Now this is all number 12, heavy oil from shale and then tar sands. You should know this is not the same kind of oil. It's kind of gross looking, not that the other stuff wasn't gross looking. And we're talking low energy yield. It's dirtier, it takes a lot to process it. So oil shale, this is a type of rock. To get shale oil, when you find this type of rock, there's gonna be a picture on the next slide. You mine the rock, you crush it, you heat it, and then you remove this stuff called kerogen. It's like black, sticky, thick peanut butter. It's pretty gross. There's going to be a picture on the next slide of kerogen in tar sands. A lot of it, which is kind of cool, is in the western United States. Now, of course, people in the western U.S. don't want mining for shale to be out by them. Here's my timer. There it is. It's all locked up in rock. It's a lot more destructive to the land to get it out, and we have to process the product a lot more. We also need to put a lot of water into it to get it out, which we know the western U.S. doesn't have. And I already mentioned low net energy yield. So what this means in general is just a lot of money spent on it. And a lot of destruction to the environment too. Okay, so this is shale oil rock. That's what it looks like. That's that heavy shale oil right there. Well, that's kind of wacky. In that beaker, okay? Tar sands is another way that we can get heavy oil. There's a fantastic movie, if you're home, not doing anything, called Before the Flood, that shows a great clip of Leonardo DiCaprio flying over Canada looking at the Alberta tar sands. So the other option here is tar sand. It's this mixture of clay and sand and water and bitumen. Bitumen and kerogen are very similar components. You see in that picture right there. It's, again, like thicky, peanut buttery type stuff. It looks like slime. It looks like black slime. So we have these deposits in Canada and Venezuela. We strip mine them. We cut down all the trees to strip mine, and it's low energy yield. So before they mine, there's this clear cutting of the boreal forest or the taiga, whatever you want to call it. We drain wetlands, we divert rivers, we dam to get it out. Okay, so these are sources of more oil, but really not ideal. However, people still do them. So heavy oil in general comes from those two places again, shale rock and then tar sand. This is a picture of strip mining for tar sands. So number 13, we're now on this page. We do have large potential supplies. They've only been recently discovered. Because we still get a liquid out, you can transport it through pipelines. That's the distribution system. Low net energy yield. Do you remember what conventional light oil is? It's medium. Still releasing CO2. It burns dirtier, and we have bigger land disruption. Excuse me. Let's move that video right there. All right, good. I don't have the slide in mind. I think this is just looking at where in Wisconsin we kind of get our energy from. So if you look down here in Waukesha County, electric service, we've got natural gas that's providing to us. We have natural gas turbines or oil turbines where these spheres are, and then we have a coal burning power plant. Where is it? It's like in South Milwaukee, St. Francis area. It also shows hydroelectric, which we don't have a lot of. There's the wind farms that you see, like when you drive like towards, I don't know, like Appleton. So that just kind of makes it local for us. All right, so let's talk natural gas. We're moving on to natural gas. Typically, I would split it up and do like oil one day, natural gas another day, coal, and then nuclear. But like I'm just kind of going by time because YouTube is limiting me again. It's by keeping text, so I can't see my timer. Okay, so we have 8 minutes left. So natural gas. Okay, so oil was medium net energy yield. Natural gas is also medium. A lot of you might have natural gas stoves at home. We use it a lot for residential cooking and heating. We are on number 14, by the way. The primary gas in natural gas is methane, which we know is a greenhouse gas, right? We talked about it with cows. Fracking, again, is how we get the majority of our gas out, so we need to keep that in mind. All right, so positives and negatives of natural gas. If you're looking at a non-renewable resource, coal, oil, gas, natural gas is going to be your best choice. It emits less CO2 than the other fossil fuels. It burns cleaner in general, so what that means is less soot, less pollutants, less particles. It is medium net energy yield. It's rather versatile. You can use it to cook, you can use it to heat your home, and we have a decent amount. Don't worry about this right here. We didn't talk about LPG and LNG. But because methane is also released, we have to take that into consideration when we look at greenhouse gases. And then all those negatives from fracking, which are these two, we have to go back to, right? The polluting water, the using the water, it leaks into the atmosphere like it's hard to catch. So that should answer number 15. All right, let's talk coal. All you probably know about coal, which is probably pretty good, is that it's a dirty burning fossil fuel. So this is formed when our land plants were buried and then like compressed and compressed and compressed and compressed. It's like solid carbon. So it's our solid fossil fuel. This stat that says 42% of the world's electricity, I bet you that's different. Coal use has gone down quite a bit. And like maybe you can Google it. I can Google it. You could message me when you see this and tell me what the real number is. But coal usage is going down because we know that it's terrible for the environment. Coal is abundant. Like you can find a lot of it. We're on number 16, by the way. And when you're looking at the world's largest coal reserves, the U.S. is right up there because you need forested areas that decompose to make coal. The U.S. has a lot of friggin' trees, right? Russia is there and China is there. So 17, so how is coal formed? So 42% in the world comes from coal. I wrote down 37% in the U.S., 56% in Wisconsin. Again, that might have changed by now. So 18 then, when you're talking about issues from coal, like look at those smokestacks. This one on the bottom, I bet you've all driven past it. It's in Gary, Indiana, our favorite place to go. Some of you said you're going to go on a road trip here over this long break, because where else are you going to go? So you can go see the largest coal burning power plant. It's in Gary. It burns 3,000 train loads of coal per day. That's a lot. All right, so the environmental costs of burning coal. We've got air pollution. This is actually what my alt day lecture is going to be next. We have SO2 release, that's sulfur dioxide, that ends up in acid rain. We have a lot of soot, that's actually like black smoke, like turns your face black. Carbon dioxide, highest amount of all fossil fuels. And you actually have trace amounts of radioactive material, and then mercury. Mercury is a neurotoxin. That last bullet right there, right there-ish. People miss that one quite a bit when you're taking the quiz and the test, okay? So that should answer number 18. So now let's talk types of coal. This should be a diagram that you have, not in color, sorry about that. But you might want to pause just so you can write. I didn't need to do that. There you go. So you're going to label, let's see. Oh my goodness, I'm sorry. So right here is number 20. And then the diagram is number 19. So I do want you to label this part, the moisture content, the names, write in that heat and pressure, and then these descriptions here, I'll annotate so you know what's important. Ooh, that looks really messy. Sorry about that. But here's what you're looking at. So highest moisture, lowest heat, you're looking at something called peat. It's not actually coal, it's a type of moss, kind of. This is partially decayed plant matter, not a lot of heat. Like, it's not very useful to burn. You want to let it sit longer. Lignite, which is brown coal, has low sulfur, but like there's just not a lot of it. It's hard to find. The one that we use the most is this bituminous coal. Bituminous coal. You see the word bitumen in it, which is our anti-holding material. So there's a lot of it. It burns pretty hot, so like it works well in terms of combustion. But the key here is high sulfur. I'm gonna move this window. Okay. And then this last one is anthracite. This is what, when we were talking clean coal last time, 2 times ago, this is what people were selling as like the clean coal. So high heat, low sulfur, but we have limited supply. Okay, so we just don't have a lot. The acronym here, PLBA, my other class decided that you should remember it by remembering the phrase, please leave butts alone. Please leave butts alone. Peat, lignite, bituminous, anthracite. Good. So the next thing you're going to do is kind of label this picture of a coal burning power plant. So you've got the coal coming in right here, gets ground up, basically gets lit on fire, heats up this water in this coil, turns to steam, spins a turbine, attached to a generator, makes electricity. You've got waste heat. This is steam coming out. Okay, you got to dispose of the ash, which is radioactive and like really hard to deal with. My dad's company actually deals with it. And then you recycle the water. Okay, the turbine's a very important part. The idea of boiling water to make steam. So you're probably gonna want to pause it and label that diagram as well. So back to clean coal. So coal companies, energy companies have fought very long and hard to classify CO2 as an actual pollutant, classifying coal ash as hazardous waste, and then emissions. The 2008 Clean Coal Campaign was greenwashing, if you remember that word. Remember, there's no such thing as clean coal. Companies can add these air pollution devices to power plants to remove some of the SO2 and some of the particulates, some of the soot. But in general, coal is still the dirtiest burning fossil fuel. This is number 23. This is also where we're going to end because my time is going to run out. And we'll pick it up with number 24, slide 24 in the last video. Keep back here.